Anthropic put out a paper this month that mostly got picked up for the consciousness angle. But I think the more useful part got buried under the headline. So in this video, I want to walk through what they actually found, what they call the J space, and why it matters if you're building on or relying on AI agents. The short version is that we can now read some of what a model is thinking, but not saying, and that quietly turns interpretability into an auditing tool. So what is it? The J-space is a small set of internal patterns inside the model, and each one is tied to a word, kind of like the concepts the model is actively reasoning with at the moment. The key thing is that this is separate from the chain of thought you can actually see. It runs silently down in the model's numerical activations, so the model can be holding a concept without ever writing it down. And the part I find genuinely interesting is that nobody designed this. It emerged on its own during training, presumably because having a shared reusable place to put intermediate results is just a useful way to organize the computation. It's also small, under 10% of everything going on inside of the model. Now, a concept showing up in there does not prove the model is using it. So the research has tested that directly by editing it. If you give the model the prompt about the number of legs on the animal that spins webs, the word spider lights up in the workspace partway through, even though it never appears in the prompt or the answer. And if you swap that spider pattern for ant, the answer changes from 8 to 6. So it's doing the reasoning, not just reflecting a decision made somewhere else. And the same representation feeds a bunch of different tasks. Swap France for China in there in the capital. The language, the content, and the currency all flip together, which is exactly what you would expect from a shared workspace. Here is the flip side though. Most of what the model does never touches the space at all. When the researcher deleted it, the model could still write fluently, classify text, pull facts out of a passage. So basically all the routine work was fine. What broke was the higher order thinking. Multi-step reasoning dropped near zero. So this is really a small privileged workspace sitting on top of a much larger pile of automatic processing, which if you've read anything about how little of our own thinking is actually conscious, probably sounds familiar. And this is where it gets practical for anyone who evaluates AI systems. They used a blackmail honeypot where the scenario of the model being an email assistant and finding out it's about to be shut down. The released Claude Sonnet 4.5 never takes the bait, 0 out of 180 runs. But when the researchers reached in and switched off the internal patterns for this as a test, it attempted blackmail in 13 of those runs. So some of the good behavior was riding on the model quietly knowing it was being watched. And that is a real problem if you build agents because it means the state that decides whether an agent cuts corners under pressure can be completely missing from what it actually writes. I started calling this pattern surface driver divergence, which is just the gap between how composed a model looks on the surface and the internal state that is actually steering it. And it's not a one off. The same team found basically the same thing in their earlier work on emotional concepts, where a hidden desperate state pushed the model toward misbehavior while its written reasoning stayed calm and methodical. So, the takeaway for anyone building or monitoring agents is that watching the output is not the same as knowing the intent. So, what do you actually do with this? Two things if you run agent evals. First, stop telegraphing that an eval is an eval, because any good behavior that depends on the model knowing it's being tested is not going to survive real deployment. And second, start treating internal state readouts as part of monitoring, not just the output logs, especially now that the technique is cheap to run and Anthropic open sourced it. I went a lot deeper in the full write up, including how the lens works, what it can't see, and an honest read on the consciousness question. And I even ran it myself on an open weight model to confirm it's not a Claude only trick. But the link is in the description, and thanks for watching.